There are linear differential equations and nonlinear differential equations. And now we are going to find which is which. We have a video in the playlist below the like button going over the definition. So this is just an example. Pause it, try to solve it yourself. If you don't want to do that, you can solve it with me. Let's go through this together. For this first one, and for all of them really, we need to define what's the dependent and the independent variable. Now, we know that a prime is really a derivative, and this is really like dy with respect to something dx. And the top part depends on the bottom part. So we want to always look at the dependent variable. So for this first one, it's going to be y. Now, y for all of these, it needs to be by itself, not inside of something, not multiplied by the same thing, and it needs to be a polynomial. It is good here. It's raised to the power of 1. It's a polynomial. It's good here. It's just being derived. Not inside of anything, not touching anything. It's by itself. This is where it breaks, though, right here. And the reason why it breaks right here is because it's not a polynomial. It's y being raised to the 5th power. Since it's being raised to the 5th power, that is very bad. And that makes it a nonlinear differential equation. We only have 2 instances of y, right here and right here. Now, y is just being derived, so it's totally fine. This is a linear differential equation. What about this next one? Well, this one's not even an equation. So this one totally acts, not a function we need to look at. What about this next one? We have 2 instances of our dh. This first one is fine. The second one is not fine because notice we have a derivative, but we have a to the 4th power on the outside. Remember, our dependent variable has to be by itself, so it's going to be nonlinear, and it's a differential equation. This next one, it breaks right here because we have a y prime, which by itself is fine. However, it is inside of something, and it can't be inside of something, so this is a nonlinear differential equation. Now we move to f. This is a linear differential equation because we have a y prime by itself, we have a y with a constant, which is okay, and 3 is just a constant, it doesn't matter. This next one, we have our dependent h over dr and ds. Now, since it's over 2 separate things, it's being shared across, this one is going to be a linear differential equation. Just because it's over 2 different variables doesn't mean it is nonlinear. So as long as dh is just being derived by itself, it's good. It's a linear differential equation. Now, where this does make a difference is if it's an ODE or a PDE, but we've gone over that previously. We're not going over that here. This next one, same situation. It is going to be a linear differential equation. For I, we have 2 dependent variables. We have a df and a dg. But they're just over dx, so this is linear. This one's okay. What about this next one? Well, we have 3 instances of x. X is being multiplied by a constant here, so it's okay. And in here, it's being derived to the 57th power, and then this one's to the 3rd, or x prime, times 3, or x triple prime. So this one is just being derived. It's all good. This one's a linear differential equation. This last one, we have y double prime and y prime and y. This one breaks for all instances of here. Notice how our y, which is the dependent variable, is inside of something at all times. So this one is going to be a nonlinear differential equation.